So we're going to look at number 17. A random variable has the following probability distribution. What are the values that A and B are going to take? All right, so express in terms of A and B, the expected value and the variance, okay? So let's say we wanted to find the expected value. All you're going to do is you're going to take 0 times A plus 1 times 1 times 1/3, 1 minus B, plus 2 times 1/3 times B. Now, why is this helpful? Yeah, so this is just going to be 0, and this is going to be 1/3 minus B over 3 plus 2/3 B, which is going to be how many B? 2/3 minus 1/3 is how many B? 1/3 plus 1/3 B, or you can just say B times, not B times, 1/3 times 1 plus B. That's the expected value. You ready for the tougher one? Variance. Okay, I'm going to go. Okay, that's the expected value. Now for the variance, what we're going to do for the variance, this is a formula I gave you yesterday. It's e of x squared minus e of x quantity squared. A little bit of a pain, but we can do it. You ready, Micah? Okay, good stuff. So all you're going to do here is you're going to take the, and I didn't write this quite right. It should be e of x quantity squared. I'm going to square 0, multiply it by a. Then I'm going to square 1, multiply it by 1/3, 1 minus b, very annoying. And then I'm going to square 2, which is 4, times 1/3 of b. That is the first part. Second part is minus our answer, which was 1/3, 1 plus b, and square it. Could you finish that algebraically? Yeah, and that's all you do for the variance. So this is a formula that you're going to use. I think it's in your packet. The sum of all the x times the probability. X times, that's the expected value. For e of x squared, you just square this and multiply it by the probability and add those up. That's what he did here. And then this is just, this is e of x squared. This is e of x quantity squared. And I didn't prove those, but that's what you do. Okay, you talked me into it. Let's go to number 22. 22 is the one you're probably going to have the most trouble with, and I want to make sure everybody can handle it. The random variable x in the binomial distribution such that mu is equal to 9 and the variance is 3.6. Find the expected value of x squared plus 2x, and then find the probability of x equal to 2. This is a beautiful paper 1 problem that you could expect on an IB test. It looks absolutely horrible, but it's not. You need to rewrite e of x squared first. So would you write e of x squared plus 2x? There's a breakdown that I talked to you about yesterday, which says that this is a split of e of x squared plus 2e of x. So far, so good? Now, Will, how am I going to handle this thing? I don't have the data. All I know is a mu and a variance. How am I going to figure out what e of x squared is? Yep. That's what you're going to do is you're going to say the variance was e of x squared minus e of x quantity squared. Now, e of x is mu, right? So I can say that e of x squared is going to be the variance squared plus mu squared. Okay. Did I lose anybody there? Is that all right? So this is going to be mu squared, which is 3.6 plus, or the variance delta squared, and then mu squared is 9 squared plus 2 times e of x, which still is mu, so that's times 9. So with your calculator, what is 3.6 plus 81 plus 1.8? Double check, make sure I did this right. Oh, no. No, I thought that was 0.9. It's times 18. Yeah. And what do you get? What's that? .6, exactly. It's easy to get those mixed up. And what do you think? Pretty impressive, huh? So go back, turn to your neighbor, explain how I broke this down, and then how I found this. Go. All right, so continuing on, we are not done yet. You got the 102.6. That is e of x squared plus 2x. But now what we want to do is find the probability of x equal to 2. So what you're going to do for that is if mu is equal to n times p, and the variance is equal to npq, we need to find, for this one, we need, let's see, what is it for 2? You need n choose x, t to the x times q to the n minus x. Now, n, I don't know. I don't know p. I can't do this one.
Well, you can find Q.
I can find q. How would I do that?
The variance equals
3.6.
equals mu times Q.
That's right. NP is the same as mu, which is 9 in this case. So this is 9 times q. So sorry about my 9s and q's. Q is going to be 3.6 over 9. Is that 0.4? Okay. So do you like that? A probability equal to 0.4 between 0 and 1? I like that. So what would P have to be then? Very good, 0.6. Now to figure out N, we just go 9 is equal to N times P, 0.6. So 9 over 0.6, could you tell me what that is? 15. So here we go. 15, choose 2, 0.6 to the 2, 0.4 to the 15 minus 2 is 13. And don't worry, I'll take this out for you. And so 15 choose 2, I can do that in my head. It's 15 times 14 because 13 factorial goes away. 15 times 14 over 2. 14 over 2 is 7. So 7 times 15 is 105. 105. 0.6 squared will be times 0.36. I don't know what 0.4. You have to use your calculator for that one. And let's see what that probability is. It needs to be between 0 and 1. Point what? I I think it's going to be tiny. 1, 2, 3, 2, 5. Not very much, is it? Not very likely. And if you look at 0.000254, how we do on that? Are you feeling a little more confident with those? Yeah, Diogo. How'd I get Q? All right. I did it very cleverly with Anne's help. Mu is NP for a binomial. Flip a coin 50 times. If it's a half is the probability, how many heads should I get? N times P. The variance is a little harder to visualize, but it's NPQ. Well, because mu is NP and variance is NPQ, can you see how I just put this 9 in here? Isn't that neat? I love these. I love these little shortcuts. 2 quick things to just review. E of 2x plus 3. That is going to be 2e of x plus 3. Variance of 5x plus 2. What that's going to be equal to is going to be 5 squared times the variance plus 0. You don't add anything. There's no variance. The 2 doesn't do anything to change the spread. So just remember those will be helpful.